So let's continue on with this lesson and take a look at powers of 10 in large numbers, and we're going to look at that base 10 system. Okay. Each place value, okay, for a number can be written as a power of 10. Now you may have noticed in the previous video there when we went through these ones, okay, these are a place value, right? The tens, hundreds, thousands, 10,000s, 100,000s, millions, and so on and so forth, and we can go into the decimals as well. So every single value or every single place value can be written out as a power of 10. Okay. Now, if a number is multiplied to a power of 10, the answer is that number with the decimal place moved according to the exponent of the power of 10. Now that might sound a little bit weird, but let's take a look at exactly what that does. And we're going to look through a couple examples as to what that means. 4 times 10 to the power 3. Now 10 to the power 3 is 1,000, and so this is 4 times 1,000. Okay, you'll notice here this becomes 4,000. The 4, we moved the decimal place over 3 spots. Okay, and so I'm going to show that over here. The decimal place on 4 got moved over 3 spots to here, and we added 3 zeros, so this becomes 4,000. Okay, so 4 times 1,000 gives us 4,000. You'll notice how the number here doesn't change, it's just the 4. It's in the 1,000 spot, and so we multiply it by 10 to the power of 3, which is a base of 10 or a power of 10. If we're doing it with the negatives instead, 5 to the power of negative 3, this is going to take the 5 and it's going to move our decimal place over 3 spots, 1, 2, 3 right here, and so we're going to have 0.005. Okay, we move it over the other way. Remember, this is the same as 5 times 0.001, which again gives us 0.005. And if you do that with a calculator, you'll definitely get that. Okay, the 10 to the power of negative 3 moves that decimal place over. That means that this number is the same as 0.005, and that's where it's located. Okay, with any number, the value of the number can be written out as an addition statement using power of 10 or using base 10. Something like this here, 4,500, can be written out using powers of 10, looking at each individual place value. So the first one to look at here is the 4,000, or that 4. That is 4,000, so that is, we can write it out, and I'm going to write it out in kind of separated. You might have seen this form of addition in the past. This is 4,000 plus 500. And if we put that together, we get 4,500. We can write them both out in powers of 10. So this is 4 times 10 to the power of 3, because there are 3 zeros, plus, and I'm just going to put this into brackets, okay, 5 times 10 to the power of 2, because there are 2 zeros. And so this is writing it out in something called base 10. Now this might seem a little bit exaggerated or a little bit long compared to what you could have just written out as 4,500, but we're going to come into how this really affects and how this deals with scientific notation and writing out really big numbers in the very, very near future, okay, on the next page. So let's try a couple of more examples here. Let's write each number as an addition statement in base 10. Well, 5,060 is the same as 5,000, which is our one number, plus 60, which is our second one. 5,000 can be written out as 5 times 10 to the power of 3, and 60 is written out as 6 times 10 to the power of 1, okay, because there's 1 0. So this would be the way of writing out 5,000 and 60 and putting it together again in base 10. Next one here is a little bit longer. Okay, we have 1 billion, 3 million, and 30,000. Okay, a big number, right? So 1 billion can be written out as 1 times 10 to the power of 9, because there are 9 place values directly behind it. The 3 can be written out as 3 times 10 to the power of 6, because there are 6 places behind it. And this second 3 can be written out as 3 times 10 to the power of 4, as there are 4 spots behind it. This right here would represent our big value here of 1 billion, 3 million, and 30,000. in terms of base 10. We take each one of our place values that's a non-zero. Okay, again, these are non-zero ones, right? I don't need to write down the zero ones because they're just zero. And when I add them together, I would come up with this value right here, or that answer right there. Now, if we have a decimal, this is just a little bit different. This will be, the 4 right here is 4 times 10 to the power. Now, the decimal place was moved over 3 spots, so it's -3. And the 3 is a little bit farther. It's moved over 5 spots, so it is -5. And these would be written out in our base 10, again, our base 10 system, but now we are dealing with a decimal, and so those two are in fact, they're negatives instead of positives. Now, one example that I didn't give, but you could see it on your assignment, is if in fact there was if there was both numbers on one side of the decimal and the other side. So let's say we had 5060 point something, we could then add a negative exponent in there as well. All right, let's put each of these addition statements into standard form and see exactly what that's going to look like. Well, 4 to the power of 4 is the same as a 4 with 4 zeros behind it, 40,000. And 3 times 10 to the power of 3 is a 3 with 3 zeros behind it. If we add those together, we're going to get 43,000, and then we're going to add in trailing zeros to finish it off. Okay, so we add in those trailing zeros to finish it off, or to add in the rest of our place values. Anytime we do not have a place value mentioned here, we need to add a 0 in there. So here, 9 times 10 to the power of 8, we're going to have a 9, and there's going to be 8 zeros behind it. So then our next one would be 7. Well, there's no 7, so we put a 0 there. 6, nothing with a 6. Then we have a 5, so we put that 4 in there. 4, there's nothing. 3, nothing. 2, nothing. 1 has a 2. And I'm going to add my commas, okay, after every 3. And so you'll notice that this number right here is 90,040,002. Okay, 90,040,002. This is the 90 million part, this is the 40,000 part, this is the 2 part. Final example that I'm going to show you here is one that, again, we're dealing with decimals here. So the first number here is 4 times 10 to the power of -2. So that means that we have to add a 0 before we get the 4 because it's 2 spots in. And then the next one is 5, so we have to add the third one, the fourth one, and then the fifth one is this number in fact. So our decimal would be 0.04005. Now I don't ever add in commas with decimal places because we don't, it's just, we could do a space if we wanted to, but we're not going to add any commas in there. But you'll notice that the zeros go in places that we don't have a number for in base 10. Now, questions 3 to 5 are for you to continue, continue on with. And if you haven't finished numbers 1 and 2 yet, make sure you get those done as well. Fill in those charts and get those 2 questions done. Then work on numbers 3 to 5, dealing with the base 10 system, and make sure that you're writing it out in clear form like this or in standard form as like this.